Hi everyone, we're going to find the Taylor series for f of x equals cosine of x centered at a equals pi. So we're going to rewrite it in this format here and write it as a sum. So let's crank out some derivatives that we're going to need. If we have n is 0, then we have f of pi, and that's what this, let me write this in red. That first term is going to be. So this is going to be equal to cosine of x evaluated at x equals pi. And that equals -1. Now for 1, we have f prime of pi. That equals negative sine of x. When you evaluate that at x equals pi, that equals 0. For 2, we have f double prime of pi. That equals negative cosine of x. When you evaluate that at x equals pi, that equals 1. And let's do 3. F triple prime of pi equals sine of x. We're evaluating this at x equals pi. And that equals 0. And let's go one more time to make sure we get back to -1. So at 4, we have f, fourth derivative at pi, and that's going to be cosine of x. And you evaluate that at pi, that gives you -1. So it starts repeating. Therefore, if you write your f of x equals cosine of x and write it in this form, I know it's hard to see. By the way, I have these on my Facebook page if you ever want to save them. So this is going to equal the sum k equals 0 to infinity, and we're going to have f of k, or f, the k derivative at pi divided by k factorial times x minus pi to the power of k. So let's go ahead and expand this. And when I expand this, I'm going to leave out these zeros. I'm only going to put in this one and this one and this one, because the zeros are going to cancel everything out. So basically we're going to skip every term here. So let's look and see what I mean. So basically we're going to write, the first term we got was -1, and then we're going to skip this term here because that's going to be 0. So the next one's going to be x minus pi squared divided by 2 factorial. Then we're going to have minus, so that's that one. And then we're going to skip a term because of the 0. We have x minus pi to the power of 4 divided by 4 factorial plus x minus pi to the power of 6 divided by 6 factorial. Then it's going to be minus, and then dot, dot, dot. So let's write this as a sum to infinity. So n equals 0 to infinity, and we have -1 to the power of n plus 1, because we're skipping a little bit here. Our first term is -1. So we want to put this n plus 1. Now we're going to have our x minus pi. We're going by even powers, so this is going to be to the power of 2n. And also our denominators are even factorial, so that's going to be 2n factorial. Now we got to find the radius of convergence. So remember this here because we're going to use the ratio test on it. You might want to pause and write this down. So using the ratio test, we're going to have the limit as n approaches infinity of a sub n plus 1 divided by a sub n. This is going to equal, I'll put it here, the limit as n approaches infinity. And I'm just going to put the absolute value on my x part. So this is going to be absolute value of x minus pi. And then since we're adding 1, it's going to be 2n plus 2. And divided by 2n plus 2 factorial. Now when we divide by a sub n, that's the same as multiplying by the reciprocal. So that's going to be 2n factorial divided by x minus pi, and this is going to be absolute value here, to the power of 2n. Simplifying this, we get the limit as n approaches infinity. And what happens here is the 2n's cancel. So we basically just have absolute value of x minus pi squared. And for this part here, I can write this as 2n factorial divided by 2n plus 2 times 2n plus 1 times 2n factorial. Just keep going down 1. So those cancel out, and you're left with 2n plus 2 times 2n plus 1. Now this equals 0, which is less than 1 for all x. Therefore, our radius of convergence is infinity. Thank you. Have a nice day. Bye-bye.